Hey there, and welcome! This is the very first explainer in a massive 20-part series where we are going to dive deep, and I mean deep, into vestibular physiology. Think of this first video as our map for the entire journey. It's the "you are here" sign, so we all know where we're heading. Okay, so first things first. This entire 20-video journey is grounded in this fantastic review article you see right here. The Physiology of the Vestibular System, from mechanotransduction to spatial cognition. We're essentially going to unpack this piece by piece together. So to kick things off, we really need a new framework, a new way of thinking. We're going to move way beyond some of the older, maybe simpler ideas about what the vestibular system is actually doing. And here is the absolute key. For the longest time, we all thought of the vestibular system as just this simple reflex organ, right? But what we understand now is that it's the body's primary inertial guidance system, a really high-speed computational network. It's not just firing off reflexes, it's actively building the brain's internal map of the world. It's responsible for our spatial awareness, our ability to navigate, and for fine-tuning our motor control in real time. And that idea, that's the central theme for this entire series. Okay, so if it's a computer, how does it compute? Well, to figure that out, we have to follow the signal. So we've structured this whole series as a journey, tracing that vestibular signal right from its origin in the inner ear all the way up to our conscious perception. And this just lays it out perfectly. It all starts with a tiny mechanical force. I'm talking a nanometer scale wiggle of these little hair-like things called stereocilia. That physical movement gets instantly turned into an electrical signal, which is then coded into nerve impulses. From there, it's shot off to the brainstem and the cerebellum for some serious processing and fine-tuning. And only then does it travel up to the thalamus and cortex to create what we actually perceive, which in turn drives our behavior. And, knowing every single step in this pipeline, that's how we as clinicians can predict what's gone wrong with our patients and why. Okay, so that's the theory. But how does this abstract pipeline connect to what we actually do every day in the clinic? Let's take a look. Right, here's the crucial point. Our clinical tests, they're not just simple pass-fail checks. It's not just a, yep, it works, or nope, it's broken kind of thing. They are precision instruments. They're physiological probes. Each one is specifically designed to stress a very particular part of that signal chain we just saw, and it does so at a very specific frequency. And this is exactly why this stuff matters for your practice. Just look at this table. Take the video head impulse test, the VHIT. That's a probe for the high-frequency function of the semicircular canals, that initial super-fast reflex. On the other hand, calorics and the rotational chair, they're testing the low to mid-frequency responses, which tap into the brain's ability to sustain that signal. Then you've got VEMPs, which give us a window into the otoliths, the parts that sense gravity and linear acceleration. And finally, the subjective visual vertical test, that checks the integrity of the brain's gravity sensing pathways. You see, each test gives us a different, vital piece of the puzzle. All right, let's zoom back out for a second and look at the full roadmap for this series. This is the entire journey we have ahead of us. We're going to start at the very beginning, in the periphery, exploring the absolutely fascinating world of biomechanics and fluid dynamics. From there, we'll go down to the molecular level with hair cell transduction, then figure out how the nerve actually encodes these signals and explore the complex architecture of the vestibular nuclei. We'll even cover pharmacology, the control theory behind our reflexes, the critical computational role of the cerebellum, and the pathways that lead to the cortex to create our sense of self in space. And we'll wrap it all up with rehabilitation principles and a final executive summary. It's the whole shebang. So before we wrap up this intro, let's just boil all this down to the three most important ideas, the big takeaways I want you to carry with you through the whole series. First up, the vestibular system is a multi-level control system. It's built on speed, integration, and, importantly, prediction. It's not just reactive. Second, and this is so important for us as clinicians, every test we use is a physiological probe. Understanding exactly what it's targeting is the absolute key to interpreting the results correctly. And third, remember our journey. This whole series follows one continuous pipeline, all the way from the tiniest mechanical event in the ear to the complex, amazing perception of our place in space. So now that we have our map, where do we begin? Well, in our very next video, we are diving straight into semicircular canals, geometry, and Steinhausen hydrodynamics. We're going to explore why we have three canals that cover all axes of rotation, how their physical size determines their sensitivity, and how a single elegant equation can predict pretty much every canal-driven response you will ever test clinically. I really hope you'll join me for that one. Thank you so much for listening. To explore more topics on dizziness, vertigo, and imbalance, and to get a whole bunch of resources for both clinicians and patients, please visit us at australiandizzinessclinics.com. And hey, if you found this helpful, please subscribe and think about leaving a rating. It really helps.